Okay, so today wraps up 15.1. So this is kind of technically part 2 of what we started yesterday. And one thing that we need to remember when we are solving equations involving an exponent. So that's what I want you to first notice about all 4 of these problems. Okay? That there is an exponent connected to your variable. Do you see that? Yes. Okay? So just like with all the other operations, to get my variable by itself, I had to do the inverse operation, right? If there's multiplication connected to my variable, I'm going to divide. If there's addition, I'm going to subtract. And we talked earlier in this lesson, so technically yesterday, about what the inverse of squaring a number is. Does anybody remember the inverse, or what kind of undoes a square? The opposite of a square is the square root. Okay, so remember, I kind of wrote one up on the board, but the square root of 64 squared, and that kind of, those inverse operations cancel out. So if I want an equation, if I want an exponent to cancel out so I can get my x by itself, I can take the square root of x squared to get x by itself. Again, the square root is the inverse operation of a square. But if I take the square root of one side, what do I have to do to the other side? Take the square root of the other side. What's the square root of 81? 9. Is it true if I plug it back in? Is 9 times 9 81? What about negative 9? Is negative 9 times negative 9 81? Yes, it is. Okay, so because it's both, I'm going to write it just like I did yesterday, positive and negative 9. And guys, every single problem that you solve that involves a squared variable will have a positive negative answer, because a negative times a negative is still a positive. All right, so now let's come over here to k squared equals 169. I want you to go ahead and solve that one just the same way that we just solved the first one. All right, so again, to undo that square, to get rid of this square that's connected to k, I need to do what? Take the square root. Whatever I do to one side, I have to do to the other. And k equals positive negative 13. Positive negative 13. Did you remember the positive negative? Yes. Okay, so now let's go down to the bottom left problem. Now, not only do I have an exponent of 2, but I also have multiplication connected to my variable. So my rule says that I do the square root last, that I have to first get everything else to the other side. Well, if multiplication is what's connecting my 3 and my a, what am I going to do to both sides to move the 3 to the other side? I'm going to divide. Divide by 3, both sides. And now my 3's cancel, and I have a squared equals 16. Okay, now that all that is left connected to a is my exponent, how can I get rid of my exponent? Square root it, both sides, and a equals, positive negative 4. All right, what do you notice about the last one?
Subtraction.
Okay, it's got some subtraction in there. Okay, so I take it a step at a time. Remember, I add and subtract first. All right, is there anything I could add or subtract to the other side? Yes, very good. I need to add 6 to the other side. And now I have 4b squared equals 196. All right, now I want you to go ahead and finish solving that problem. All right, so what am I going to do?
You got to put 4 over on both sides.
Divide 4 by both sides, and b squared equals 49. And square root both sides. And b equals? Nope. Positive negative 7. So if you just say 7, you're only going to get half credit. Okay, so don't forget the positive, negative when you're solving equations. Why is it positive and negative?
Because you can like multiply with, if they're both positive, you can multiply them and get the same answer. If they're both negative, you can both multiply and get the same answer.
Yeah, negative 7 times negative 7 is 49. Okay. All right, so we have this last one, and we call it a challenge question. You know, it just looks a little different. Why do you think it looks a little different?
Because it's backwards.
It's backwards. Okay, so you can totally write it the opposite way also, as long as 7b squared minus 385 is on one side and negative 42 is on the other side. A lot of people just like reading it, you know, basically forward. All right, now I need to solve for b. So what would I do first over here on the left side? I need to do my addition and subtraction first. Okay, and now 7b squared equals, what's negative 42 plus 385? Basically, what's 385 minus 42? And it is 343.
Got it.
Okay. Miles, what is the next step?
It's, so then you have to divide it.
Yep, by?
7.
Yep. And what'd you get?
B equals 49.
B squared, yes.
Squared equals 49.
Okay, now what?
B equals 7.
Okay.
Plus negative whatever. 7.
All right. So this is actually not completely correct. Based on the instructions he gave me, what did he forget? All right, and it's written up here on the screen. He did not show, maybe you did on your paper, but you didn't say it. You have to show the square root. You say, well, Miss Kinder, don't you know that's what I did? Because obviously that's what I did, but you didn't show me. Okay? So yes, you have to show that. So that's a lot of what I catch when I'm walking around and looking at your papers. You say, oh, well, you know, like I know, you know that I was doing that. Well, yes, but you have to show it. Okay? So we're not done. We're not done. Okay? I need to introduce you now to a concept called upside down division to solve for very large square roots. Okay? Upside down division to solve for very large square roots. Okay? So let's start with a really big number like 900. 900. If I asked you, well, no, that's too even, because there's another way I could solve that. Hold on. Okay, so let's do 576. 576. This is a number that's large enough that, okay, once you know the square root, you could memorize that, but you're going to have a section of numbers on your quiz and your test next week that you're not going to necessarily have the square root memorized. And hitting your handy-dandy square root button on your calculator really doesn't teach you a whole lot, especially about simplifying radicals. Now, this number is what we call a perfect square. What does it mean for a number to be a perfect square? Okay, yes, the square root is a whole number, meaning two numbers can be multiplied to equal that number. So I am looking for a whole number. But what if I just gave you a number that was not a perfect square, but it was a really, really big number, like 500 and something? So this upside down division method helps you simplify square roots, whether they are perfect squares or not. And the not part is what you're going to face in Algebra 1, okay? So I'm kind of laying the groundwork for what you're going to see next year. So here's what we do. We can't just say, oh, I have this memorized, or at least we're acting like we can't. So let's do upside down division. This might be a method that you learned with prime factorization last year with GCF. But we need to divide it by a prime number. Okay, by a prime number. So just start with the smallest prime number. Prime numbers are numbers that are only divisible by 1 and the number itself. 2? Because it's an even number, let's go 2. What's 576 divided by 2?
252.
288. Now this part you can use your calculators for to do the division part, but you still need to show the work. Can 2 go into 288?
Yes.
Okay, 144. Can 2 go into 144?
Yes.
Yep, how many times?
72.
72. Okay, can 2 go into 72?
Yes.
How many times?
34.
36. And then 2 goes into 36?
18.
18. And then 2 goes into 18?
9.
9. Okay, 2 goes into 9. Oh, sorry. 3 goes into 9. 3 times. Okay, now the prime factorization is done because the bottom number is a prime number. All right, so this is more or less mindless because we're only dividing by very small numbers. Okay, now I'm going to go back and circle each pair. One pair of 2s, another pair of 2s, another pair of 2s, and a pair of 3s. So every number is in a pair. And for each pair, I'm going to write it 1 time. 2 times, 2, 3 times. Okay, and then 2 pairs of 3s, right? No, 1 pair of 3s, sorry. Okay, so 2 times 2 times 2 times 3 is what?
24.
24. Okay, so fingers crossed. All right, I'm just kidding. I know this is right. But go ahead now and use your calculators to find the square root of 576. To just confirm.
I don't have
Okay? So use your calculator to confirm the square root of 576.
How do you do that?
You just do 576 and hit the square root button. Okay? What is it, guys?
24.
Okay, square, or you could just say 24 squared. Either way. But yes, we can confirm that. You say, Ms. Kinder, why in the world would I do that when I could just hit the button? Because you don't have the button on the test. On your SAT, your ACT, your PERC test. You don't have the button. They expect you to be able to simplify a radical, which that's technically what we're doing here. When it's a perfect square and when it's not. You will, 100%, you will see this in Algebra 1. So I need to introduce it to you now. I'm going to give you perfect squares, okay? But eventually, next year, they will not all be perfect squares. There will be numbers left over. All right? So on your homework tonight, I need to be clear on this, okay? I would encourage you, if you do not know the square root, to use this method, okay? I will not technically take off for that on your homework, but there will be a section on your quiz on Monday where I say use upside down division to find the square root. So it's better that you practice now, okay? And that's all you need to know for 15.1.